Yeah, so now it just went crazy again. All right. Let me see if okay. Oh, where's my glasses? Yeah, let me put my glasses on so I can see. Okay. All right. And let me make sure I have this thingy on. Okay. Right. Let me see. Okay, guys. I'm trying to read, but I'm like not, getting focused. So you know what, you guys are gonna have to just join me, log off when you feel like whatever. But I'm not gonna do this by myself. No, I'm not. Hi, Ingrid. No, we're gonna do this together because I can't focus. Now, anatomy and physiology. Explain the importance. This is just for me. This is not for you guys. If you want to log off, if you want to stay, it's okay. But I figured let me do it on the platform so I can focus. So I'm not paying nobody no mind. Okay. Explain the importance of the relationship between structure and function. Anatomy is the scientific discipline that investigates the body's structures. For example, the shape and size of bones. The word anatomy means to dissect or color apart and separate the parts of the body for study. In addition, anatomy examines the relationship between the structure of a body part and its function. Okay, anatomy is the relationship between the structure of a body part and its function. Okay. Thus, the fact that the bone cells are surrounded by a hard, mineralized substance enables the bones to provide strength and support. Color girl Ingrid, bless upon herself. Understanding the relationship between structure and function makes it easier to understand and appreciate anatomy. Anatomy can be studied at different levels. Okay. You have developmental anatomy, embryology, cytology, histology, and gross anatomy. Developmental anatomy, embryology, cytology, histology, and gross anatomy. Read it in there. Developmental anatomy studies the structural changes that occur between conception and adulthood. Embryology is a subspecialty of developmental anatomy. Consider changes from conception to the end of the 8th week of development. Some structures, such as cells, are so small that they must be studied using a microscope. Cytology examines the structure features of cells, and histology examines tissues. Okay. Cytology is where you examine the structure of the cell. And And histology examines the tissue composed of the cell. Embryology is where you deal with the anatomy from the beginning of conception, when the egg fertilizes, until the 8th week. It's the embryo. Good? That's why it's called embryology. Okay, I got it. All right, girl, go ahead. Now, gross anatomy. Wait there. Oh, okay. Gross anatomy studies the structures that can be examined without the aid of a microscope. And which ones are those guys? You got the skeletal muscle, the heart, the lung, the liver, you have all these things. Okay. A system is a group of structures that have one or more common functions, such as the cardiovascular, nervous, respiratory, skeletal, or muscular systems. In systemic anatomy, the body is studied by system to system. In regional anatomy, the body is studied area by area. Wanna take this thing easy? Hey. Good. Now, in a system, these structures have one or more common function, right? Such as the cardiovascular, the nervous, the respiratory, skeletal, or muscular. In systemic anatomy, the body is studied by system. In regional anatomy, the body is studied area by area. Within each region, such as the head, abdomen, or arm, all systems are studied simultaneously. The regional approach is taken in most graduate programs at medical and dental schools. The systemic approach is used in this and most other introductory textbooks. This is what I'm doing, guys. So I'm just reading because I need to read. Maybe there now. Oh, God, me gone all the way up. Okay. This is just for my brain, for tomorrow. Where the thing there? All right, I lost the cursor thing. Okay. So why this thing don't move? So this thing is like a crow seat here. Okay, there we go. Okay, so we did that. Okay, all right. Surface anatomy involves looking at the exterior of the body to visualize structures deeper inside the body. For example, the sternum, the breastbone, and parts of the ribs can be seen and palpated, felt on the front of the chest. Health professionals use these structures as anatomical landmarks to identify regions of the heart and points on the chest where certain heart sounds can best be heard. Okay, so these structures are called surface anatomy because you can feel them, chest bone and, these things, right? You can feel them. Okay. And anatomical imaging uses radiographs like X-rays, ultrasound, magnetic resonance imaging, MRI. Anatomical imaging uses radiographs, X-rays, ultrasound, magnetic resonance imaging, MRI, and other technologies to create pictures of internal structures. Anatomical imaging has revolutionized medical science. Anatomical imaging allows medical personnel to look inside the body with amazing accuracy and without the trauma and risk of exploratory surgery. Although most of the technology used in anatomical imaging is very new, the concept and earliest technology are quite old. In 1895, okay, dates to remember, 1895, Wilhelm Röntgen became the first medical. There. Okay, well, it disappeared wherever it is. Okay. Hold on, what's up? All right, that's because I've exposed it all the way up. Okay, he became the first medical. You see how much reading you have to do? Okay, wanna think it's easy. Hey. That's why when the people them attack and I carry on, I just have to say, wanna keep on chatting, man. Okay. He became the first scientist to use X-rays to see inside the body, right? So now I have to remember that Groetten, some kind of name like Groetten, 1892, he was the first scientist to use X-rays inside the body. Yeah, I know a lot of people are not interested, but it's good to be, learn a little bit about something other than the same laba nonsense. Good edify on the brain. It only takes a couple, minutes, but for me, it's a couple of hours because I have to do this, right? So I might as well bring you with me because uno lazy and disgusting, and uno no want to read nothing, but uno go and read today or uno can log off. Good, okay. The rays were called X-rays because no one knew what they were. Ain't that something? I learned something today. The rays were called X-rays because no one knew what they were. Whenever the human body is exposed to X-rays, ultrasound, electromagnetic fields, or radioactively labeled substances, a potential risk exists. The risk must be weighed against the medical benefit. Numerous studies have been conducted and are still being done to determine the effects of diagnostic and therapeutic exposure to X-rays. Okay, we don't need to read all of that. We just need to get to the nitty-gritty because, this is what we need in order to pass an exam. Okay, we know about all of that. Okay. However, no two humans are structurally identical. Anatomical anomalies are physical characteristics that differ from the normal pattern. Okay, test question. What is an anatomical anomaly? An anatomical anomaly are physical characteristics that differ from the normal pattern. Anita Clark, my darling. Vicki Lewis, my love. And God bless Debbie, my darling. Okay. Anatomical anomalies can vary in severity from relatively harmless to life-threatening. For example, each kidney is normally supplied by one blood vessel. But in some individuals, a kidney is supplied by two blood vessels. Either way, the kidney receives adequate blood. On the other hand, in the condition called blue baby syndrome, certain blood vessels arising from an infant's heart are not attached in their correct locations. Blood is not effectively pumped to the lungs, and to the tissues. And so the tissues do not receive adequate oxygen. Physiology is the scientific investigation of the processes or functionings of living things. What is physiology? Okay, physiology is the scientific investigation of the processes or functions of living things. The major goals when studying human physiology are to understand and predict the body's responses to stimuli and to understand how the body maintains conditions within a narrow range of values in a constantly changing environment. Like anatomy, physiology can be considered at many levels. Cell physiology. Wait, hold on. Oh, wait, hold on, I missed something. Like anatomy, physiology can be considered at many levels. Cell physiology. How them write that like that? Oh, because I'm reading it wrong. Because there's a period mark. You see that? Because I'm reading it wrong. Like anatomy, physiology can be considered at many levels. Period mark. Okay, that's why you have to read. Very important. Cell physiology examines the processes occurring in cells, such as energy production from food, and systemic physiology considers the functions of organ systems. Okay. Cell physiology examines the processes occurring in cells. Okay. Systemic physiology considers the functions of the organ systems. Okay. Types of systemic physiology are cardiovascular physiology, which is your heart, which focuses on the heart and blood vessels, and neurophysiology, which is your nerves and so forth. Neurophysiology, which focuses on the function of the nervous systems. Studies of the human body must encompass both anatomy and physiology. Pathology is the medical science dealing with the aspects of disease, with an emphasis on the cause and development of abnormal conditions, as well as the structural and functional changes resulting from disease. Exercise physiology focuses on the changes in function and structure caused by exercise. And we ain't gonna go into all of that now. This is the chemical level, right? You guys might not be too privy, but some of you guys might be. This is the chemical level, right? So with the chemical level, you have the atoms. These are atoms, right? And they combine to form molecules. Now, on the cell level, the molecules form organelles, such as the nucleus and the mitochondria, which make up the cells. Now, on the tissue level, right? On the tissue level, you have similar cells surrounding materials that make up tissues, right? Okay. On the organ level, you have the different tissues combine to form organs, such as the urinary bladder. And there you'll have the organ system level. Organs such as the urinary bladder and kidneys make up an organ system. Here is a DNA molecule. This is what we're made up of, right? This is the DNA. It's a double-stranded helix, right? And then here you have the mitochondria, which provides energy to the cell. And, they are found in the smooth muscles. And here is an example of a smooth muscle. And here's the cells. This is the nucleus, right? Those are the nucleuses. Isn't that fascinating? This is on the cellular level. This is the cellular level. Hi, Angela, my darlings, right? Okay, this is what we have to do in school. Now, here, you have the urinary system, right? And it contains your kidneys, urethra, your urinary bladder, urethra. Test question. Name the structures of the urinary system. Angela, best up yourself. Oh, okay, these are test questions. Name the structures of the urinary system. So you know there's 5. You see the 5 right there? So you have kidney. Yeah, 1 missing. 1, 2, 3, 4. Oh, Lord, something missing. Wait, the next. Oh, the bladder. Oh, wait. Anyway, hold up. Anyway, let's just figure it out. Okay. You got the urethra. You got the urinary bladder. You got the urethra. Oh, no, wait. You got the urethra, the urinary bladder, the ureters, which are those 2 tubes, and the kidney. Oh, because you got 2 kidneys. Yo! Okay, wait. 1, 2. 1, 2, 3, 4, 5. There you go. See that? You got the 2 kidneys. 1, 2, 3, 4, 5. No, wait, no. You have, wait. Wait. You got 1, 2, 3, 4, 5. There you go. So you got the ureter, and then you have the 2 kidneys. So in the urinary system, you have 5 structures which enable you to what? Pee. Okay. Up here, so is the urinary bladder. This is our urinary bladder, ladies. We be having some weak bladders and stuff, right? And up at top, what's this? Okay, yeah. This is the urinary bladder. And then here is the wall of the urinary bladder. And it's made from epithelium. This is the epithelium. Then you have the connective tissue. Then you have the smooth muscle tissue, which helps the transition of the urine. And then you have the connective tissue. And this is the wall of the urinary bladder. I thought that was my son calling me, right? So that's that. So these are the things we have to know, guys. We can't just be blabbing and talking stuff without education. Oh, no, we can't. So this is where you have the simplest level of organization in the human body is the atom. Atoms combine to form molecules. Molecules aggregate into cells. Cells form tissues, which combine with other tissues to form organs. Organs work in groups called organ systems. And all organ systems work together to form an organism. You guys are not paying attention in class. Are we ever not giggle with one another? Pure pink and Ingrid again with our nonsense. She's not paying attention. We're the one, we're the one Debbie there. Right? That's why Una can't learn nothing in class. Because all Una do is wave and giggle. and chit chat and create all this excitement. Why wanna keep doing this thing? Cha! Where we there? Okay. I should put you to the test, you Miss Ingrid. Name this. Me want you to write down 5. How the structure them in the urinary system. Me want you to write it down. 5 of them. We just went over it. You, Ingrid, name them. Write them down. Not say nothing, Debbie. You've been very good, well behaved, quiet. Ingrid, 5 structures of the urinary system. Write them down right now. Write them down. Good. While you're giggling and wave and chat to people and you're supposed to be paying attention in class, you did a greet. That's why you can't learn nothing. And then the one lady not get me started mad then because she come in here. Miss Campbell is sitting at the back of the class quite nice. Me I go set her up on her. You watch me and when she walk in here tonight. Because Miss Campbell, she there in the back where she belong. Because you know fear brain no right. Okay, good. Here we go. Now, where we did there. So you met the one latest coming here if she thinks she bad. She better just cut class for tonight. Because me I go set that the one in the back punchy. Now, Ingrid, me I wait for the answer. Ingrid, you better go Google it. You better go do something. The 5 structures that make up the urinary system. When we split there, the urinary system, I take 2-minute break because my throat dry. Wanna read up the thing, right? Yes, because I wanna love play around with the thing. Wanna read and learn something for once. Now you got 6 levels of the organization of the body. Okay. Wanna finish read this part, yeah? Because I know wanna slow. Wanna finish read this? Okay, me I go over here, so. Okay, let's go over here so they can read this while I take a 2-minute break. Okay. Let me go over here. So Ingrid, me I wait for the answer, Ingrid. Hard yet, Ingrid not come up with the answer, you know. Rotted soup here, yeah. Okay, hold on, guys, because does anybody have that cap with the big D? It's yellow. It's a big D, you know, you put it on your head. Okay, guys, let's go back up. And we're going to teach Ingrid what happened when she not pay attention. With the thing there. What happened when she not pay attention in class? Okay. All right. So make we teach her. Where the thing there? Where the thing where it move over the thing? We can't find it, Lord of God. Okay. Okay, let's fix the one, Ingrid. Oh God, the thing gone. See the thing where you know the bar thing? It's gone. Oh, here we go. Okay. Let's teach Ingrid, because you see why she greet and meeting people. You see what happened when she meet and greet? You know, see how it go. There's the answer. Because me want to know where you see pelvis. Good? And renal. Where you get that from? Oh, okay, good. Sorry, Roxanne. I thought that was your answer. Go to the back of the class with Miss Campbell. Good? Go to the back of the class with Miss Campbell because me want to know where you get kidney, renal, pelvis, bladder, urethra. You see what happens when you not concentrate and studied what the teacher is teaching or no? Me said kidney, you get one right. Urethra, nowhere in sight. Urinary bladder, you get that one partially right. Do urethra. Wait there. Where you right? Oh, it gone. Wait there. Let me find your clot. Yeah. You put bladder, but a urinary. You pelvis. We don't know where you get pelvis from. Where you get pelvis from? Renal. Is that a structure? You must laugh, Debbie. I feel your friend. Show me your friend and where you go, show me your company and me show you who you is. Me hope say you separate yourself from that one she Ingrid. Because she don't get it right on yet. Good? Okay. Now moving right. Moving right. Isn't this fun? Moving right along. Now we're going to keep up with the intelligent ones. And the one them like Ingrid who not to write it in them brain. We have to go teach them with the thing there. Okay, here we go. Okay. Now, okay, so we did, well, we didn't because, of course, Ingrid have to interrupt the whole thing with our greet and meet session. Okay. I mean, I even get this more. Okay. After reading this section, Ingrid, yeah, do you have on your bifocals? Okay, good. Perhaps you don't have on your bifocal then. Okay. After reading this section, Ingrid, you want to vote heavy. Get up. You know we have fun over here. Okay. After reading this section, you should be able to name, Ingrid, the 6 levels of organization of the body and describe the major characteristics of each level. List the 11 organ systems, Ingrid. Identify their components, Ingrid, and describe the major functions of each system, Ingrid. So you better take out your pencil and your notepad. The body can be studied at 6 levels of organization. Ingrid, chemical, cell, tissue, organ system, and whole organism. Where we there? Wrong way. We have to go up at top. Okay. Chemical level, Ingrid. The structural and functional characteristics of all organisms are determined by their chemical makeup. The chemical level of organization involves how atoms, we just went over the atoms and the cells, right? How atoms such as hydrogen and carbon interact and combine into molecules. Hydrogen, you got 2 hydrogens and 1 oxygen, and you end up with what, guys? Water, H2O. Simple, good. And then carbon, you got carbon in basically everything that we do. Carbon dioxide, carbon monoxide, and so forth and so forth. This is important because a molecule structure, oh my God, I'm not taking you guys with me. I'm sorry. Where is it? Where did you think that we can't find it? Okay, good. Okay, this is where we're reading. But I can't find that thingy. It just keeps disappearing. Anyway. Okay, here we go. Yeah. Okay. The chemical level of organization involves how atoms such as hydrogen and carbon interact and combine into molecules. I gave you an example of water. 2 hydrogens, 1 oxygen, H2O. That gives you water. Okay. Thank you, Debbie, because you a good friend. You looking out for your friend. You see, that's a good one. Okay. For example, collagen molecules. You know, collagen, we use collagen for skin and so forth, are strong rope-like protein fibers that give skin strength and flexibility. With old age, all the way we're whole, with old age, the structure of collagen changes and the skin becomes fragile and more easily torn during everyday activities. We present a brief overview of that in chapter 2. Now, the cell level, Ingrid, it deals with the cells. The cells, Ingrid, just basic cells. And these are your basic structural and functional unit of me, you, and everybody. All living organisms are structured from the unit of what, Ingrid? Cells. Okay. Now, why is the computer acting funny? Oh, here we go. Where is it? Is it this? Okay, here we go. Is it this? I can't find that thing to move the thing over. Anywho, okay. Organelles carry out particular functions, such as digestion and movement for the cell. For example, the nucleus is an organelle that contains the cells. Now, what is this? What's going on here? Okay. For example, you have the brain, right? Oh, I'm sorry, guys. Oh, here goes the line I'm looking for. Here we go. Okay. You have the brain, right? Okay. And the spinal cord. You have the lungs. You see the lungs? Where's my pen? Come on, guys, Ingrid, because when we put you under the test, me now want you to come tell me some foolishness. Good? Because me I teach you not today. When me have to go through. Oh God, where's the pen? Okay. So you wanna think this thing easy? It's not easy. So here you have your lungs, and in the middle of your chest, don't forget your heart. But it's slightly to the left, but you can see it's dead center right here, so right. Your lungs is up at top right here, so right. You see your shoulder right here. So this is where here we call this scapula, but you know this is your shoulder blade, right? And right, yes, so. And that's so. Okay, where is it? Okay, right. Here is the liver. That's at the liver. And the pancreas is behind the stomach. And your gallbladder, your kidney, and your large intestine. Here is your spleen, your stomach. This thing, right? This little thing right here, that's your stomach. The kidney, this is the kidney. And then the small intestine, yaso. If you look at the small intestine, this is where all the enzymes and everything, digestion and so forth. And if you look at the large intestine, that's where all the doodle start to form and all the big doodle them, and you see all this big thing and then everything just come out. Yeah, so, okay, good. Okay. You, Miss Ingrid. Hi, Rowena. This is the urinary bladder. Right? Okay. The body's major organs include the brain and the lungs, heart, liver, the pancreas, spleen, stomach, gallbladder, your kidneys, your large intestine, your small intestine, and urinary bladder and urethra. Okay, guys? Okay. This is what me have to go through. Okay? Good. Now, a whole heap of reading. It's horrible. But it's good for the brain. You know, it's good for the brain. Now, humans, if you want, you can read along, right? You know, at your own pace. Humans are organisms. Yes, we is. Sharing characteristics with other organisms. The most important common feature of all organisms is what, guys? Life. This text recognizes 6 essential characteristics of life. Get ready, Ingrid. Organization. Refers to the specific interrelationships among the parts of an organism and how these parts interact to perform specific functions. That's all we need to know, right? We haven't had time for all this reading, but we need to, to get the major points. Metabolism. We all deal with metabolism, which is the ability to use energy and to perform vital functions. Metabolism refers to all of the chemical, where that thing? Anyway. Where the thing there? Oh. Okay. Metabolism refers to all of the reactions taking place in the cells and internal environment of an organism. Organisms process specialized proteins and break down food molecules. The organisms then use the nutrients from the food as a source of energy and raw materials to synthesize new molecules. Energy is also used to rearrange the shape of molecules. The shape of a molecule determines its function. Some changes in molecular shape can allow certain cells to change shape. For example, specialized white blood cells can surround and engulf potentially dangerous foreign invaders, such as certain bacteria. Metabolism is necessary for other vital functions, such as responsiveness, growth, and development and reproduction. Responsiveness is an organism's ability to sense changes in its external or internal environment. Okay. Responsiveness is an organism's ability to sense changes in its external or internal environment and adjust to those changes. Responses includes actions such as moving toward food or water and moving away from danger or poor environmental conditions. Organisms can also make adjustments that maintain their internal environment. For example, if the external environment causes the body temperature to rise, sweat glands produce a sweat which can lower body temperature down to the normal range. So these are the organizations of the human body, right? Some of you guys might know, but some of you guys might not, right? But because of that, because of the content, we don't want to overdo it. Now you have the urinary system. You have the female reproductive system, and you have the male reproductive system. Hold on, guys. Let me go up a bit and see if I missed anything. Hold on. Let me see. Okay. These are the systems. Good. You got the lymphatic. You got the respiratory. You got the digestive. You got the urinary, and you got the female and the male reproductive system. And development includes the changes an organism undergoes through time, beginning with fertilization. That's when the sperm fertilizes the ova. So that would be the what they call them again? Oh God, spermatoza, right? That's when all these changes occur, and they continue after birth and throughout life. That's your development, right? That's your development. And it usually involves growth, differentiation, and morphogenesis. When you see the word morphogenesis, you know kind of what that means, right? Now, differentiation involves changes in a cell structure and functions from an immature, generalized state to a I messed it up again. Okay, to a, oh Lord, where is it? Dooby dooby doo. That's because I messed up the line, right? To a mature, specialized state. For example, following fertilization, that's, when you realize you're pregnant, immature cells differentiate to become specific cell types such as skin, bone, muscle, or nerve cells. These differentiated cells form tissues and organs. Morphogenesis is the change in shape of tissues, organs, and the entire organism. Reproduction is the formation of new cells or new organisms. Reproduction of cells allows for growth and development. All living organisms pass on their genes to their offspring. Ingrid, briefly explain what are the 6 characteristics of living things. Dooby dooby doo. Doo da 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 da. Oh, stop. Okay. Ingrid, darling. I hope you was paying attention, sweetheart, and didn't run away. Hope you didn't run away, Ingrid. Now, Okay, we did that. Okay, we did that. Ingrid, darling, are we here? Hi, Rowena. Okay. Okay, we did that. Okay. So yeah, guys, this is the reading that we have to do in school. Yes, we do. Now, um, and the reason why we have to do this, according to these wonderful professors, is that studying other organisms has increased our knowledge about humans because humans share many characteristics with other organisms. Okay. A failure to appreciate the differences between humans and other animals led to many misconceptions by early scientists. One of the first great anatomists was a Greek physician, Claudius Galen. Galen described a large number of anatomical structures supposedly present in humans but observed only in other animals. For example, he described the liver as having 5 lobes. This is true for rats, but not for humans who have 4 lobed livers. The errors introduced by Galen persisted for more than 1300 years until a Flemish anatomist, Andreas Vesalius, who is considered the first modern anatomist, carefully examined human cadavers and began to correct the textbooks. This example should serve as a word of caution. Some current knowledge in molecular biology and physiology has not been confirmed in humans. Wait. What's going on here? Yeah, so this is the readings that we have to do, guys. Okay, something's missing. Oh. Oh, that's because I'm all the way over here and I need to be over here. Okay, so let's see, what did we miss over here? Okay, this is temperature and whatever, and variables and all these things. These are the things they want us to know, all these variables and all right. Okay, so let's move this. All right, where's that line? Oh my lord. That line thingy keeps on disappearing. I can't find it. Oh, here we go. Okay. Okay, so here, I know, guys, I know you get tired, right? So what about me? The flip? What about me? Now, this is the negative and the positive feedback. Perhaps you've heard of this, but don't really know what it means, but I do, but we keep hearing it. Okay. So, this is good for you guys to know. Okay, we did that. Okay. You see chapter 1? This is a chapter 1, you know? Okay, I want to take this thing easy. It not easy. I wish I could just leave the phone the way it is, but the computer, I act like I can't move the computer, my own computer. That's how I act. Like it. Okay, Ingrid, you know what, Ingrid? Just read. Okay, now we're going to read about homeostasis. I know a lot of you guys have heard this term, but might not know what it means. Oh Lord, look what I went and did. You know what? I went into a whole different thing here. Dooby. Oh. Wait. You know what? Dum dee dee dum 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 dee dum dum. All right, these are all the chemical bonds and the trains and all of that. Yeah, we ain't got to that yet, so let's go. Let's go. I had to download this book. Okay, that's chapter 2. Okay, this is chapter 1. Yeah. Let me see how much more chapter 1 I gotta go. Oh my Lord. Body parts, do that. Terminology, do. You see how much thing we have to read? No, sir. Ready? Okay, here we go. This is where we at. You see how much reading? Okay, now. Homeostasis. Why is it important to recognize that humans share many but not all characteristics with other animals? Okay. I know, right? Only thing, this thing, me know, man. When you hear the term homeostasis, it is the existence of maintenance of a relatively constant environment with the body. To achieve homeostasis, the body must actively regulate conditions that are constantly changing. As our bodies undergo their everyday processes, we are continuously exposed to new conditions. Change in our environmental conditions, such as hot or cold outdoor temperatures, are called variables because their values are not constant. For cells to function normally, the volume, temperature, and chemical content of their environment must be maintained within a narrow range. One of the most well-known examples of homeostasis is body temperature. Good, guys? So whenever you hear someone speaking about homeostasis, you will know that it has to be body temperature because that's one of the well-known examples of it. And that's your body temperature. Body temperature is a variable that increases when you are too hot and decreases when you are too cold. Homeostatic mechanisms, such as sweating or shivering, normally maintain body temperature near an ideal normal value or set point. Note that these mechanisms are not able to maintain body temperature precisely at the set point. Instead, body temperature increases and decreases slightly around the set point to produce a normal range of values. As long as body temperature remains within this normal range, homeostasis is maintained. And that's another term where we use equilibrium, right? No matter what the situation that's going on in your body, once you go through homeostasis, it maintains a normal range of values in your body. Note in figure 1.4 that the normal body temperature range is no more than 1 degree Fahrenheit above or below normal. Our average body temperature is 98.6 Fahrenheit. Just as your home's thermostat does not keep the air temperature exactly at 75 degrees Fahrenheit at all times, your body's temperature does not stay perfectly stable. The organ systems help keep the body's internal environment relatively constant. For example, you got the digestive, respiratory, cardiovascular, and urinary systems work together so that each cell in the body receives adequate oxygen and nutrients while also ensuring that waste products do not accumulate to a toxic level. If body fluids deviate from homeostasis, body cells do not function normally and can even die. Disease disrupts homeostasis and sometimes results in death. Modern medicine attempts to understand disturbances in homeostasis and works to re-establish a normal range of values. Now, when you have the negative feedback, where's the thing? One of the examples of that would be is that the positive or the negative? Hey, hold on. Okay. The negative feedback is this, that most systems of the body are regulated by negative feedback. Yeah, right. Exactly. Yeah. Okay. Labor is positive feedback. Okay. And it's regulated by negative feedback mechanisms which maintain homeostasis. In everyday terms, the word negative is used to mean bad or undesirable. Okay, hold on a minute because I'm missing something here. Okay, we read that. Okay, because I read a lot. That's why I'm looking. Okay. Oh, okay. All right. All right. We're almost there. All right. All right. Okay, so now. Okay. Wait. This thing is very confusing because I don't know if I'm reading backwards or leftwards or what I'm doing here. What is this? Okay. Has not been confirmed in humans. Okay. In this variable, okay, we have to see because now I'm confused. Okay. In this variable is okay, yeah. In this variable is a stimulus because it initiates a homeostatic mechanism. Several negative feedback mechanisms regulate body temperature, and they are described more in chapter 5. Normal body temperature depends on the coordination of multiple structures which are regulated by the control center or hypothalamus. That's your control center in the brain. If body temperature rises, sweat glands, which are the effectors, produce sweat and the body cools. If the body temperature falls, sweat glands do not produce sweat. The stepwise process that regulates body temperature involves the interaction of receptors, the control center, and the effectors. Oh, so we should have read up and down. Okay. And the effectors. Okay. In this, the other hand, if body temperature drops, the control center does not stimulate the sweat glands. Instead, the skin blood vessels constrict more than normal and blood is directed to deeper regions of the body, conserving heat in the interior of the body. In addition, the hypothalamus, which regulates temperature, guys, the hypothalamus regulates our temperature in our core body. In addition, the hypothalamus stimulates shivering, quick cycles of skeletal muscle contractions, which generate a great amount of heat. Again, once the body temperature returns to normal, the effectors stop. In both cases, the effectors do not produce their responses. Although homeostasis is the maintenance of a normal range of values, this does not mean that all variables remain within the same narrow range of all values at all times. Okay, so we move down because we ain't reading all of that. Okay, we did it. Okay, doop. Okay, glucose. Okay. Now, Ingrid. What is the gland which controls your body temperature called? Caribbean honeybee. We're putting Ingrid to the test because she loves wave and chat. Okay, Ingrid, we're waiting for you because I'm taking a break before we move forward. Now, Ingrid, what is the gland which controls our core body temperature? Come on, Ingrid. Let's go. Come on, Ingrid, if you're here. We're gonna give Ingrid 2 minutes to answer. If Ingrid does not answer, then one of you can add. God have his I can't breathe. I cannot breathe. I can't. Ingrid, I'm going to have a heart attack. Ingrid said, you know what? She said hypothermia, and then she go to hypo. Ingrid, what is hyper and what is hypo? Me want you to tell me, Ingrid, what hyper mean. Hypo. Now, Ingrid, you're wrong on all aspects, so make we go back up because she now pay attention. She said hypothermia, and she said hypothermia. So let's go back up to the word which I look for, because I never see this in all my days. Me too. But me just say it 2 seconds ago. 2 seconds. 2 seconds. Don't make up no excuses, you woman, you. Wait there, let me bring it up big and bold for you. See it, yeah? Hypo, you get a part of it right. Hypothalamus. Okay, lady? Hypothermia is when you're hot. Hypothermia is when you can't see. Yeah, all right, watch out. Look. You can't put on your glasses. You can't see hypothalamus. You can't see this, Ingrid? Debbie, you must laugh because it shouldn't have a fear bifocal. Something wrong. Who no can't see the word? No, sir. If you can't see this, Ingrid. Okay, you see it now. No, man. Okay. All right. Whew. Okay, moving right along. Me have my glasses, them to you, no girl. Okay. So it's hypothalamus. I know you guys will. There you go. Debbie. Are you sitting next to Ingrid, Debs? Just asking for a friend. Doobie doo. How did you do da do We can see who's paying attention here. Okay, I'll stop picking on Ingrid because glasses ain't working right and so forth. So let's just stop now. I'm gonna have a heart attack. Debbie, I love you, Deb. Whoa! With friends like these, who need enemies? Who need enemies? With friends like these, who need enemies? Oh God. Let me get back to the reading. Okay, guys, this is where we're there now. Positive feedback mechanisms. Mechanisms occur when a response to the original stimulus results in the deviation from the set point becoming even greater. In other words, positive means increase. That's childbirth, guys, right? Okay. At times, this type of response is required to return to homeostasis. I love you, Ingrid. I love my Ingrid. She's sitting back. I didn't say it. Debbie did, Ingrid. She said she'll sit. Ah. Oh, God. Okay. All right. Let's start from the beginning. Okay. Positive feedback mechanisms occur when a response to the original stimulus results in the deviation from the set point becoming even greater. In other words, positive means increase. At times, this type of response is required to return to homeostasis. And the number one example for that is childbirth, guys. Yes, it is. For example, during blood loss, a chemical responsible for blood clot formation called thrombin stimulates production of even more thrombin. In this way, a disruption in homeostasis is resolved through a positive feedback mechanism. What prevents the entire vascular system from clotting? The clot formation process is self-limiting. Eventually, the components needed to form a clot will be depleted in the damaged area, and no more clot material can be formed. Birth is another example of a normally occurring positive feedback mechanism. Near the end of pregnancy, the baby's larger size stretches the uterus. This stretching, especially around the opening of the uterus, stimulates contractions of the uterine muscles. The uterine contractions push the baby against the opening of the uterus and stretch it further. This stimulates additional contractions, which results in additional stretching. The positive feedback pressure to drop even further, a deviation further from the set point. The additional decrease in blood pressure further reduces and blood delivery to cardiac muscle, and the heart pumps even less blood, which again decreases the blood pressure. Hold on. Because I'm reading, oh, you see, I missed a whole portion. Okay. Because the thing is big, because I tried to make it big for Ingrid so she can see. I'm, missing stuff. Okay, so when I leave here up top, because I just missed, because I know it really doesn't make sense what I was reading now, right? Because we went into blood pressure. Okay. This stimulates additional contractions, which result in additional stretching. This positive feedback sequence ends only when the baby is delivered from the uterus and the stretching stimulus is eliminated. Two basic principles about homeostatic mechanism to remember are that many disease states result from the failure of negative feedback mechanism to maintain homeostasis, and some positive feedback mechanisms can be detrimental instead of helpful. One example of a detrimental positive feedback mechanism is an inadequate delivery of blood to cardiac heart muscle. Contraction of the muscle generates blood pressure, and the heart pumps blood to itself through a system of blood vessels on the outside of the heart. Just as with other tissues, blood pressure must be maintained to ensure adequate delivery of blood to the cardiac muscle. Following extreme blood loss, blood pressure decreases to the point that the delivery of blood to cardiac muscle is inadequate. As a result, cardiac muscle does not function normally. The heart pumps less blood, which causes the blood. Right there. Hold up. Which causes the blood to, because I know right here is not right, right? Where the thing there? Which causes the blood. Where is it? All right, so anywho, that's because this thing is so big that I'm losing the parts where I'm at. Okay, we did the positive feedback mechanism. Okay, we did the positive. I'm almost done, guys, but you can go. It's okay. I just wanted to be able to do this, so I could read. But I appreciate you guys hanging out with me. I really do. And at least you get to learn something. All right, we did that with the baby. Okay, the heart pump. Okay, the heart pumps the blood. Okay, you know what, whatever. Anyway, you guys know what's up, right? Okay, and then the last part is the anatomical position. I know this because then we go into part 2, right? I know this because this is what we went in class. This is what we did, right? Let me see if see? Am I lying, guys? No, this is chapter 2. See? Now I gotta do chapter 2, but I won't do that with you, right? So that's chapter 2. Okay, so the last part is the anatomical positions, which I can do by myself. You don't really need to be here. I just wanted you guys to be with me so I could continue reading without not reading. So I'm glad I was able to bring you guys with me because it was fun. Now I'm trying to get, this bloody thing. Oh my goodness. Where is that arrow thing so I can get to the other side? Where is it? It keeps disappearing. It keeps disappearing. I can't find it. Anywho. So this is the lungs and so forth, right? We went through, here we go. Okay. And we went through that. And this is the inside. This is the this is your GI. This is your gastrointestinal tract, right? Good. Right? This is the mesentery. Okay, that's where all of the arteries and veins and so forth, right? The membranes, right? And we call that, this is the pericardium, the visceral pericardium and the pericardial cavity. Is it? Wait, am I showing you the right thing? Yeah, right? Yeah, good. And these are the membranes that cover the lungs, the visceral pleura. The pleural cavity is where all the liquid is filled. And then you have the peritoneal cavity and so forth and so forth. So this is a review. See, they give you a review, which you could read and so forth. All right. And we did all of this. And these are some of the questions they give you so you can go over. And this is chapter 2. Ain't you guys proud that you did the whole of chapter 1 with me? You actually did the whole of chapter 1 with me, other than doing the body planes. Wait, let me see. Yeah, other than us doing this part, right, which is the planes of the body, right? You did everything else with me, guys, and I really appreciate it. We did up to here. We did up to, not the blood pressure. We did a little bit of the blood pressure. Yes, you did. Ingrid just say she's the, you know what? The who you the valedictorian of? Listen here, lady, don't make me I have it about valedictorian. Is your name Creator? But you're bright. Valedictorian? But at least just spell it right. Okay, all right. Oh, yeah, valedictorian. You better go sit down, about valedictorian. If anybody have valedictorian, not Debbie, because at least she get the answer them right and she can spell and all these things, and she don't need bifocals. Mr. Ingrid really is very delusional. Okay, so we did that. Yeah, we did the body temperature. So this is where we left off, guys. Look. You know, the body temperature and so forth. And you guys went with me all the way. Let me show you where you guys went. You guys went with the thing day. It's always disappearing. Okay, here we go. We did all of this. Look, we did all of this. Look, all of this we did. We did all of this. Look at that. Look. You see how much reading gonna do? Watch out. Oh, how come we ain't do this? Oh yeah, yes we did. This was the MRI and the radiation and the X-rays and so forth. Remember, we did all of that, but we ain't got to look at all of this because we know. But anyway, this is when they look into your brain. So that's called a CT scan, computed tomographic, which is a CT scan, right? And it was developed in 1972, and it was originally called a CAT scan, right? Okay. This one is a DSA, which is a digital subtraction angiography, and that goes into the brain, and the information is put into a computer, and then a dye is injected into the blood, right? Into the blood, and they do what they need to do with that. Okay, good. This is the MRI we were talking about earlier, magnetic resonance imaging, which is a direct radio waves at a person lying inside a large electromagnetic field, and the magnetic field causes the protons of various atoms to align. Because of the large amount of water in the body, the alignment of hydrogen atom protons is most important in this imaging system. Radio waves of certain frequencies which change the alignment of the hydrogen atoms then are directed at the patient. And when the radio waves are turned off, the hydrogen atoms realign in accordance with the magnetic field. The time it takes the hydrogen atoms to realign is different for various body tissues. These differences can be analyzed by computer to produce very clear sections through the body. And MRI is more effective at detecting some forms of cancer than a CT scan. Okay, so we did all of that. Yes, we did, guys. We read all of this. Remember the ultrasound, and another one is the ultrasound, where this is the second oldest imaging technique, right? The ultrasound. It's the second oldest imaging technique. And it was developed early in the 1950s from World War II, sonar technology. And it uses sound waves, which are emitted from a transmitter receiver placed on the skin over the area to be scanned. and the sound waves strike internal organs and bounce back to the receiver on the skin. Even though the basic technology is fairly old, the most important advances in this field occurred only after it became possible to analyze the reflected sound waves by a computer. The computer analyzes the pattern of reflected sound waves and transfers the information to a monitor to be visualized as a sonogram, as you can see. And you can see your baby because you took a sonogram. Okay, guys? And this is what we covered in this time. And I appreciate it so much where you guys hanged in there with me and you helped me to read the whole of chapter 1. And you should be applauded for that. And I appreciate it, right? So we got through chapter 1 and we had fun with it. See, this is chapter 1, right? And we did it, you and I together. Ingrid, my darling, my valedictorian, yeah, right. Thank you, sweetheart. I love you, Ings. And God bless Debbie, your girlfriend over there. So she's laughing like crazy. But I'm glad that we did this because it's fun. And of course, we can do more. And Janet Newbold, Caribbean Honeybee, bless up your good self, darling. Rowena, Janet again. Roxanne, my love, mad them, mad out. Well, you know she didn't come, right? Debbie, Ingrid, Angela, Janet, Angela, Anita, my love. Yeah, Debbie again, Madam Amadal, thank you, sweetheart, for joining me. Color Girl, bless up your good self, Color Girl. Ingrid, my darling, are you, yeah, you present and I'm quiet. No, you ain't. I love you guys. I really appreciate you hanging out there with me. I really do. Anywho, I'm going to hang up because I know you can't wait for me to turn off. Hey, I'll see you guys later. Love you guys. Mwah.